Hey guys, in this video we're going to start talking about solving quadratic equations by factoring. Before we dive into how to solve these problems algebraically, let's take a look at what it looks like graphically. So if you look at page 42 in your notebook, it says that the solutions of a quadratic equation are found when the equation is set equal to 0. Note that that's the same thing as y equals 0. Therefore, the solutions of a quadratic equation are also the x-intercepts of that function when graphed. So at the bottom or on the left side here, it has a little sketch of a parabola, which is a U-shaped graph. And you can get several pieces of information from that graph. You can find the axis of symmetry, which is kind of hard to see on your graph, but it's basically the invisible line that runs through the vertex. You can also find your solutions, which are your x-intercepts, and you can tell where the y-intercept is as well. And lastly, you got the vertex down here at the bottom. Now, sometimes the vertex can be at the top. It's basically where the curvy part of the graph happens. So it curves here and goes back up. So it was going down and then goes up, and the place where it changes direction is the vertex. This vertex here is called a minimum because it is the low point of the graph, but you can also have one that is a maximum where it is the high point of the graph like this. All right, so let's take a look at an example, and we're going to find each piece of information from the graph. It says, draw the axis of symmetry and state the vertex and the solutions. So let's start by finding the vertex. Remember what I said. The place where it changes direction is the vertex, and that is an ordered pair. Remember that ordered pairs are always x comma y. So we have 1, -9 as our vertex. The x-intercepts are the place where the graph touches the x-axis. In this case, there are two. There's one of them at -2 and one at 4. You can also write these as ordered pairs. So in this case, it'd be -2, -4, or excuse me, -2, 0 and 4, 0. Those are your two solutions. One thing you don't want to do is separate it by a comma, because then it might be mistaken as an ordered pair, which it is not. It's important to know that you're not always going to have two solutions. It's possible to have just one, and it's also possible to have no solution, and we'll get into that later. Now, the y-intercept of this graph is right here. I'm going to write this one as an ordered pair. That's 0, -8. And as I mentioned earlier, the axis of symmetry is the invisible line that runs through the vertex. So in this case, it would be right here. Now, if you think back to last semester when we talked about writing equations of special types of lines, we talked about Hoy versus Vux. This one, since it's a vertical line, it is a Vux. So that means my equation is going to start with x equals, and it runs through 1. So it's x equals 1. A way that some people like to remember it is that the axis of symmetry is always x equals whatever the x value of your vertex is. And that's it. That's all you would have to do. Now, down here at the bottom, it says a polynomial is in factored form if it is written as the product of two or more linear factors. So that is the last chapter that we talked about. When you have two sets of parentheses like this right next to each other, that is factored form. Now, according to the zero product property, the product of two factors is 0 when at least one of the factors is 0. That's a fancy way of saying if I set one of the insides of the parentheses equal to 0 and solve for x, that's how I can find the solutions of the graph. And again, solutions of a quadratic function can also be called the x-intercepts. And there's actually two other words that you might hear used as well because, you know, math likes to be complicated, so it's got to have a bunch of names for the same thing. They're also called roots or zeros. So you'll hear me say all four of those interchangeably, so just know that they all mean the same thing. All right, take a look at the next page. Up at the top of page 43, there are the solve by factoring steps. Step 1 is to set the equation equal to 0. So what that means is you have to get it into standard form and so that it is equal to nothing but 0. So sometimes you'll have to move the constant over, or some term might have to be moved over to the other side, and we'll see that here in a minute. Once you've done that, you can factor the quadratic expression and then set each factor equal to 0 and solve for x. So essentially, we are doing the exact same thing that we did in the last chapter, but now we're taking it one step further. So let's see how this works. All right, in the first example here, we have x plus 9 times x minus 1 equals 0. Well, we've already taken care of the first step. It's already equal to 0. Step 2 is to factor it. Remember what I said, it's in factored form if you have two sets of parentheses right next to each other, which is exactly what we have. So we don't even have to do step number 2. We can go directly to step 3. Set each factor equal to 0 and solve for x. So these are the factors here. There's one factor, here's another factor. So I have x plus 9 equals 0 and x minus 1 equals 0. And I'm going to solve each of them for x. So subtract 9. And my first solution is x equals negative 9. For this one, I'm going to add 1. And I get x equals 1. So the solutions are negative 9 and 1. All right, so now we're going to sketch a graph showing the solutions. First of all, you know that the solutions always end up on the x-axis here. So I'm going to put 1 point at negative 9, which is right here, and 1 point at 1, which is here. Now, you don't know how to calculate the vertex yet, so we're not going to worry about figuring out what that is before we sketch. But one thing that you need to know about a quadratic function is how to tell whether it opens up, so that means the arrows point up, or whether it opens down, which means the arrows point down. And all you need to do is look at the very front of your equation and decide or see what sign is there. If there's no sign, that means it's positive. And then if there is a negative sign there, that means it is negative. Positive quadratics open up, negative quadratics open down. So since I have no sign, that means I'm positive, which means eventually this is going to extend upwards. So both arrows are going to extend up, and then it's going to connect with a U shape like this. So again, we're just sketching. You're not worried about making it perfect. You need to make sure that you hit where the zeros are and the arrows need to be going in the correct direction. That's all I'm looking for here. In the future, we'll learn how to graph it correctly. All right, let's try another one. This one, again, is already factored for us and equal to 0, so we can skip straight to step 3. So x minus 4 equals 0. And x plus 3 equals 0. Solve each equation. Which tells me my solutions are 4 and negative 3. I'm going to put 1 point on 4, 1 point on negative 3. And once again, there is no negative sign in front, which means I open up. So I'm going to sketch going this way and connect in the middle like that. All right, letter C. This one's in standard form. So standard form means that the exponents are in order from biggest to smallest. Notice that it's already equal to 0, so we don't have to worry about that. So now we just need to factor. So we're going back to those factoring skills that we just used in the last chapter. A is equal to 1, which means I can use the big X method. So I'm going to find all the factors of negative 14. It's 1 and 14, 2 and 7. Since I need to multiply and be negative, the signs of my pairs are different, but I need to add and be positive, so the small ones are negative. The one that works is going to be negative 2 and 7. So I end up with x minus 2 times x plus 7. And remember that we're now equal to 0. In the last chapter, we weren't equal to anything, so we didn't worry about that. But here we are, so we're going to still have it equal to 0. And then the last step is to take each set and set it equal to 0 and solve. So x minus 2 equals 0, and x plus 7 equals 0. I'm going to add 2 here to get x equals 2, and subtract 7 here to get x equals negative 7. So my solutions are 2 and negative 7. So I'll plot a point at 2, a point at negative 7, and once again, no sign in front, so I'm going to open upwards and connect in the middle. There's my quadratic. All right, one more here. Same thing. We need to first have it equal to 0. This one is not equal to 0, so all I'm going to do is take this 15 and subtract it on over to the other side. So now I have x squared plus 2x minus 15 equals 0. Now it's in standard form and I can factor it. Once again, a is equal to 1, so I can use the big X. The factors of 15 are 1 and 15. 3 and 5. And this should be negative 15 because there's a negative in front. So that means my signs are different. Once again, the middle is positive, so I'm going to choose to make the smaller numbers negative. And this right here is the pair that works. So I'm going to have x minus 3 times x plus 5. And once again, it's equal to 0. Now to finish this off, I just need to do each one equal to 0. So x minus 3 equals 0. X plus 5 equals 0. Add 3 on this one. Subtract 5 on this one. So these are my two solutions, 3 and negative 5. Here's negative 5. Here's 3. Again, it's positive in front, so I'm going to open upward and connect in the middle. All right, turn the page. Sometimes you don't have to sketch. In fact, 99% of the time, I'm not going to make you sketch, so it's important to know how to do each of these problems. All right, so we have already done ones like these. You might see them in factored form already, and when that happens, all you need to do is set each part equal to 0 and then solve. So 2x minus 3 equals 0, and x plus 5 equals 0. So add 3. 2x equals 3. Divide by 2. X equals 3 over 2. There's my first answer. And then subtract 5. I get x equals negative 5. There's my second answer. Both are answers. You got to have them both. All right. Number 2 here. X squared minus 5x minus 84 equals 0. It is not already in factored form, so we're going to have to get it there. But it is already equal to 0, so we can go straight into factoring. So negative 84 is the number I need to find all the factors of. So 1 and 84, 2 and 42, I believe 3 works, 3 and 28, 4 and 21, 5 doesn't work, 6 and 14. Hopefully we're getting to the end here because I'm running out of space. 7 and 12. 8 does not work. 9 does not work. 10 isn't going to work. 11 does not work, and we already have 12. So that's all my factors. Again, this is negative, so my signs have to be different. The middle is negative this time, so I'm going to make all the big ones negative. And I need the one that adds to negative 5. And that's going to be this one right here. So I have x plus 7 times x minus 12, and that's equal to 0. And then once again, to solve, I'm just going to do x plus 7 equals 0, and x minus 12 equals 0. Subtract 7. X equals negative 7. That's my first answer. Add 12. X equals 12 is my second answer. And that's it. All solved. All right, number 3 is similar to that last example that we had on the last page, except this time it's the 13x that's over here on the right side. I'm going to do the same thing and move it over, but it's important to remember that these need to be in standard form in order for you to factor them correctly. So that means this x term needs to be in the middle here. So I'm going to have x squared minus 13x plus 42 equals 0. Got to be in standard form. Now I can factor. Find all the factors of 42. So I have 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, 6 and 7. All right, this time it's positive, so my signs have to be the same, but the middle is negative, so everything is negative. The pair that works is negative 6 and negative 7. So I have x minus 6 times x minus 7 equals 0. And then set them equal to 0. So x minus 6 equals 0, x minus 7 equals 0, and you should end up with x equals 6 and x equals 7 when you solve each one. Now, some of you might say, well, isn't my answer just the opposite of the numbers that I pick? And as long as there's no number in front of x, yes, that is true. So if you can jump from here straight to your answer, I'm totally fine with that. I just want to make sure you understand how to get there. All right, number 4. This is the first one we've had where a is not equal to 1. So the first thing that I'm going to do anytime I see a problem where a is not equal to 1 is I'm going to see if there's a GCF. So 4 is the biggest number it could possibly be. 4 goes into 16 and into 20 as well. So what I'm going to do is divide that 4 out. So now I'm going to have 4 parentheses, x squared minus 4x minus 5, and it's still equal to 0. Now to factor this, I need to find all the factors of negative 5, which is pretty easy. It's just 1 and 5. And I need to be negative when I add together, so I'm going to make this one negative. So now I have 4 times x plus 1 times x minus 5, and it's still equal to 0. Now, you got to be careful if there's a GCF. If your GCF has a letter with it, which this one doesn't, but if it has a letter with it, it means you're going to get a solution from it. If you don't, you can ignore it. Because think about it. If I set 4 equal to 0, that doesn't make sense because 4 is not equal to 0. So I will not get a solution from this. But I am going to get a solution from each of my parentheses. So x plus 1 equals 0 and x minus 5 equals 0. So I end up with the solutions x equals negative 1 and 5. Those are my 2 answers. All right, I'm going to leave number 5 for you to do on your own because it's the same as number 1. Let's take a look at number 6. First thing I'm going to do is subtract 11x, and you should notice that that has an x with it, so it's got to be the middle term. So 2x squared minus 11x minus 6 equals 0. So once again, there is a number in front of the x squared. So my first thought is, let's see if there's a GCF. Unfortunately, there's not though, because this 11 here is a prime number. It's not divisible by 2. So that means there is not a GCF. So I am going to have to factor this by split the middle. Later on, you'll find another way to actually solve this type of equation, but for now, we're just practicing using factoring, so that's what we're going to do. So 2 times negative 6 is negative 12. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. My signs are going to be opposite, and I need to be negative when I add, so I'm going to make the big ones negative, which means this is the pair I'm going to use to split the middle. So now I have 2x squared plus 1x minus 12x minus 6, and it's still equal to 0. Now I can factor by grouping. Here I can take out an x. Here I can take out a negative 6. When I divide, I get 2x plus 1 and 2x plus 1, and it's still equal to 0. So my parentheses match, which means I've done it correctly. So when I factor, I have 2x plus 1, not equals, times x minus 6. That is equal to 0. Now, if I were to solve this, I can easily figure out what this one is. I'm going to get x equals 6. But 2x plus 1 might not be something as easy to recognize what you would get, so I'll show you the work. I'm going to subtract 1 to get 2x equals negative 1, and then divide by 2 to get x equals negative 1/2. So here's one answer, and the other is x equals 6. So yes, it is possible to get fractions. It's also possible to get decimals, but if you can have a fraction, I would prefer that. All right, bottom row. It says the graph of which function has x-intercepts 5, 0, and negative 2, 0. Now remember what I said, you can write your solutions as ordered pairs. So this means I have x equals 5 and x equals negative 2. Now remember, when we talked about this one, I told you if you can go from this to that, knowing that the solutions are just the opposite of the 2 that you chose, you can easily go backwards. So knowing that my solution is 5 means I need to have the opposite of that inside my parentheses. So I have to have it say x minus 5. Well, when I'm looking at my options here, A does not have an x minus 5, and neither does C. So I know it's not either one of those two. Now, negative 2, the opposite of that is positive 2, which means I need x plus 2 inside, which means B is the correct answer. All right, I'm going to leave 8 for you to do. 9 says, how is factoring the expression x squared plus 3x minus 18 similar to solving the equation x squared plus 3x minus 18 equals 0? Okay, it is similar in that you follow the same steps. So factoring each expression is the same. It's different in that the equation requires setting each factor equal to 0 and solving for x. So like I said at the beginning of this video, solving quadratics is the same as factoring them. You just have to take it one step further. And the next page is partner practice. So you're going to do that in your groups, and that's it. That's how you solve quadratic equations by factoring.